Most everyone is aware, I guess, that we're still cutting down trees to pave and build stuff all over the United States. But a new research project, using a sophisticated approach to Google Earth images, shows just how large and widespread the losses are, and with impressive precision. In the 5-year period between 2009 and 2014, American cities and suburbs lost approximately 175,000 wooded acres per year. That's about 36 million trees annually, and an overall decline in the wooded portion of these metropolitan landscapes from 42.9% to 42.2%, which may seem small until you begin to consider, and price, the consequences. Trees bring quite a wide array of benefits, environmental, medical, spiritual, to their communities, and researchers from the U.S. Forest Service looked closely at just 4 that are comparatively easy to monetize. Conclude that wooded acreage contributes services worth $18.3 billion a year to American cities and suburbs by cleaning air, capturing global warming carbon dioxide, cooling the urban heat island, and lowering energy consumption. They feel a conservative but reasonable valuation for tree losses at the levels they measured is $96 million per year, which also might seem small until you consider how long it takes to replace a mature, productive tree. Indeed, among all the complicating factors of geographic sampling, land use classification, image interpretation, etc., addressed in this paper, the massive tree replanting programs undertaken in some cities just didn't make much difference. It simply takes too long for a new tree to be visible to a satellite, let alone reach a size that delivers much ecological service. No change in Minnesota among the 50 states, plus District of Columbia, where urban tree losses were measured. Only 3 had urban, community areas where wooded acreage increased, and their gains were statistically insignificant. 3 others, Minnesota, Alaska and Wyoming, showed essentially no gain or loss. All the other states all saw wooded acreage decline significantly, with the largest loss rates in Oklahoma, Rhode Island, Oregon, Georgia and the District of Columbia. The impervious cover of the built landscape, roads, buildings, parking lots, grew by 167,000 acres during the 5-year span, and no state posted a decline. The largest rates of expansion were in Delaware, Iowa, Colorado, Kansas and Ohio. Just as forest cover delivers benefits, impervious cover adds costs, higher temperatures and energy use, more air pollution, amplified flooding, lowered water quality. The work here was done by David J. Novak and Eric J. Greenfield, both of whom work at the Forest Service's Northern Research Station in Syracuse, New York. They've been at this kind of inquiry for a while now. The new research, which updates and extends the findings of earlier investigations, was published this month in the journal Urban Forestry. Drawing on Census Bureau definitions of urban areas, determined by population density, and communities, using municipal boundaries, Novak and Greenfield have identified what they call urban community areas, an overlapping, metropolitan sort of territory they define as where most people live. Though we can all agree that Google Earth is pretty awesome for everyday searching, it presents some difficulties for the serious scientist. Resolution can be variable, and so can the accuracy of date labels. However, if you can come up with a geographically valid sample of 100,000 readable pictures of the land surface, as this team did, half from the start of the 5-year study period, paired with half from the ending year, you're getting somewhere. What you've got is a lot of work for human interpreters, trained to look at each of those 50,000 image pairs and decide what percentage in each is forested, and how that changed over the 5-year period. A second set of interpreters was used to re-examine a random sample of the first group's work in search of errors. They didn't find many, because you're also interested in how much land has been made impervious by development. You also count the change in that acreage, covered with roadways, buildings, parking lots and the like. What's left over forms a category of land covered with grass or other herbaceous cover. Yes, there is also a category for agricultural land, but almost by definition it lies beyond the urban community zone that was the focus of this study, and so was ignored. as was water everywhere. Interestingly, though not inevitably, impervious acreage increased over the 5-year period of the study at a rate nearly identical to forest loss, 0.6 of a percentage point. But that isn't because we pave every cleared acre immediately. 60% of it goes to the grass, herbaceous column, if only temporarily. And it's on land in that green but treeless sector where most new impervious surfaces appear. Also interesting, tree losses in the denser urban cores were about 40% higher than the overall metropolitan losses, though logic would suggest that's not where the most intensive clearing for new development would occur. Of course, while development seems to be the main driver of metropolitan forest loss, there are others. Some are natural and unavoidable: aging, ordinary disease, lightning strikes. Others are less so: invasive insect infestations. The emerald ash borer has claimed essentially all the ash trees Detroit planted to replace its lost elms. Wildfire, think of last year's ring of flame around Los Angeles, and big storms. Did you know New Orleans lost 30% of its shade trees to Hurricane Katrina? An array of health benefits. If the Novak Greenfield statistics on tree loss and its costs leaves you unimpressed, consider the growing body of research showing that trees deliver a range of benefits to urbanites' health and happiness far beyond slightly cooler temperatures and somewhat cleaner air. Several studies have shown that exposure to green spaces can be psychologically and physiologically restorative by promoting mental health, reducing non-accidental mortality, reducing physician-assessed morbidity, reducing income-related health inequalities' effect on morbidity, reducing blood pressure and stress levels, reducing sedentary leisure time, as well as promoting physical activity. In addition, green space may enhance psychological and cardiovascular benefits of physical activity, as compared with other settings. Moreover, experimental research has demonstrated that interacting with natural environments can have beneficial effects, after brief exposures, on memory and attention for healthy individuals and for patient populations. In addition, having access to views of natural settings, e.g., from a home or a hospital bed, have been found to reduce crime and aggression and improve recovery from surgery. I quote there from a fascinating paper published a couple of years ago by an international team of scientists headed by the University of Chicago's Omid Cardin, who figured out a way to correlate the presence of street trees in Toronto, as documented, on almost a tree-by-tree basis, in satellite images and city records, with similarly fine-grained health data gathered in a long-term, ongoing survey of 225,000 city residents. The results, they wrote, suggest that people who live in neighborhoods with a higher density of trees on their streets report significantly higher health perception and significantly less cardio-metabolic conditions, independent of health advantages associated with socioeconomic status and demographic factors. We find that having 10 more trees in a city block, on average, improves health perception in ways comparable to an increase in annual personal income of $10,000 and moving to a neighborhood with $10,000 higher median income or being 7 years younger. We also find that having 11 more trees in a city block, on average, decreases cardiometabolic conditions in ways comparable to an increase in annual personal income of $20,000 and moving to a neighborhood with $20,000 higher median income or being 1.4 years younger. Not saying you should go hug that linden at the corner, but it couldn't hurt. The Novak Greenfield paper, Declining Urban and Community Tree Cover in the United States, can be found here but access is not free. The Cardin paper, Neighborhood Green Space and Health in a Large Urban Center, can be read here without charge.